All right, continuing with problems from Holiday and Resnick, edition 10, chapter 9. This is on center of mass problems. 937. A soccer player kicks a soccer ball of mass 0.45 kilograms that is initially at rest. The foot of the player is in contact with the ball for 3.0 times 10 to the minus 3 seconds. And the force of the kick is given by Ft, which is 6.0 times 10 to the 6 times T minus 2.0 times 10 to the 9 times T squared newtons. And it goes over a range of 0 less than equal to T less than equal to 3.0 times 10 to the minus 3 seconds, where T is in seconds. Find the magnitude of A, the impulse on the ball due to the kick, B, the average force of the ball from the player's foot during the period of contact, C, the magnitude, the maximum force on the ball from the player's foot during the period of contact, D, the ball's velocity immediately after it loses contact with the player's foot. So we have a lot in this problem. So let's just start with what we know we have to do. We have a T and T squared, which we know we're going to have to integrate this force. And we know it's going to be over a range of 0 to 3.0 T seconds. So to get the impulse. So the impulse of the ball due to the kick, that's A. And we know that J is equal to F delta T. So this is the formula we're going to use. So J is going to be the integral from what? From 0 to 3.0 times 10 to the minus third seconds times 6.0 times 10 to the 6t dt, that's that delta, plus 0 to 3.0 times 10 to the minus third, and this is a minus sign, to 0.0 times 10 to the 9th T squared dt. So when we do this integral, we're going to get J is going to equal 6.0 times 10 to the 6, that's just the constants, T squared over 2 minus this constant 2.0 times 10 to the 9th T cubed over 3. So J is going to equal to 6.0 times 10 to the 6. I'm going to put out 3.0 times 10 to the minus 3. I'm going to square it, put it back over 2 there, minus 2.0 times 10 to the 9th, which we've got 3.0 times 10 to the minus 3 cubed divided by 3. So, and this is equal to 18 newtons. And this will go to J is equal to 9 newtons for A. And part B says the average force on the ball from the player's foot during the period of contact. Well, we know that the average force is just going to be F is going to equal to J over delta T. We're getting it from this formula right here. And since we know J is equal to 9 newtons, and we know that it's going to 3.0 times 10 to the minus third seconds. So we know that force is going to be 9 times 10 shift to the third, taking that minus 3 up there, divided by 3 is going to be 3,000 newtons. Part C. C. The maximum force on the ball from the player's foot during the period of contact. So whenever you hear maximum force, you know you're going to have to do a derivative and set the derivative to 0. So the force is given to us as F of T equal to 6.0 times 10 to the 6 T minus 2.0 times 10 to the 9th T squared. So we'll do a derivative on that. And this is going to equal to 6.0 times 10 to the 6 minus 2 times 2.0 times 10 to the 9th times T. So what do we have? We have to set this whole thing is equal to 0. So we're going to have T, we can skip a few steps here. It's going to equal to This went on 6.0 times 10 to the 6 divided by 4.0 times 10 to the 9th, which is going to be 6 point, let's clear this, 6.0 times 10, shift to the -3, enter, 9 goes up, 9 from, -9 from 6 is a -3, divided by 4. And you get a time of 0.0015 seconds. Now that I have this time, I'm going to feed it back into my original equation here, this one here. So for the maximum force, so F of T is going to equal 6.0 times 10 to the 6 times 0.0015 seconds minus 2.0 times 10 to the 9th times 0.0015 seconds squared. And this should equal 4,500 newtons, which is going to give us an answer of 4,500 newtons. Part C. Now D, D asks us the ball's velocity immediately after it loses contact with the player's foot. So we'll say P is equal to mv. So this goes to V is going to equal P over M, which is 9 Newton seconds. I want to go back here. This is supposed to be Newton seconds. Newton seconds, not Newton's seconds. For J. J is in units of Newton seconds, which is which is momentum. Newton dot second over mass. Well, let's look at this a little bit so we make sure we are doing 9, and a Newton is kilogram meter per second square times that second there, and mass of this object, this ball, is 0.45 kilograms. So kilograms will cancel. One of the seconds will cancel. And we're going to have meters per second. That's what we want for velocity. So let's just finish this up. 9 divided by 0.45. So what we're going to get is 20 meters per second.